I work at the organization called Dealer Inspire, and we're in charge of the website platform, and we run on AWS. So all those things will be talked about here shortly. Just a little bit about myself. My title is currently Senior Software Engineer, but I do work on a systems engineering team. A lot of people refer to us as SysOps. We're kind of the place that people go to if they don't really know how to do things. So I touch a lot of different concepts and paradigms and technologies. I do a lot of system tooling. I'm currently working on revamping a lot of our monitoring and observability. And primarily our team is responsible for the infrastructure, which we run all in AWS. We're also responsible for a lot of the build systems, getting the code out into production, making sure everything's working. So that's kind of who I am in a nutshell from a technology point of view. I have a website if you're interested in learning more about me. I'm a pretty open book. I divulge most things about me. I do hold a master's in computer science. I originally started in music and quickly went over to technology after kind of figuring out where my passions lied and how I kind of operate as an introverted person. I enjoy a lot of concerts and metalcore music and films and big Blackhawks and Cubs and Bears fan. And I'm very passionate about open source and digital privacy and Linux and BSD, Python. I enjoy a good craft brew IPA. So a little bit of prerequisites, just in case anyone's not familiar with these simple concepts. Cloud computing, it's very popular. Everyone's moving to that. It's just a bunch of other servers in the cloud. AWS is an example of a vendor. It utilizes what's known as APIs to interface to create resources on demand. And like I said, AWS. And for this talk, the main concept is NFS, which is a network file system. It's been around for a while. And this talk is primarily about NFS v4. So just a little background about Dealer Inspire, because it kind of helps give a little context into this talk. The company began as a startup around 2012, 13. I joined in 2015, actually as a developer, and I quickly moved over to the systems team after realizing that I would enjoy systems work a lot more. The company started using AWS from the very beginning. So we have everything in one giant master account currently. We're currently trying to work on breaking that out into multi-accounts. So a possible future talk in the future. So the company was kind of saw an opportunity to disrupt the automotive marketing industry by creating websites and creating a bunch of products and services to do to sell cars. So we directly help out dealerships and provide them tons of services. And then in 2018, we were bought out by Cars.com. So technically, I am now an employee of Cars.com. And with that has come a lot of new opportunities, and it's just been a great thing. And I think being in a startup to an enterprise has been great for my career. I kind of see everything involved there. So the web platform architecture, this is our main product that we support. We host currently about 6,000 individual WordPress websites for dealerships. So like if you go to like toyotanaperville.com, that would be an example of one. We split them up by hosting in Apache virtual hosts. We have a redirect server that excuse me, points the A record to the www, which is what our WordPress code is actually hosted on. And that mount for var www, where all the WordPress code lives for each website, is the NFS server. And that is what this talk is all about. Currently, we refer to a collection of AWS compute resources as a pod. So I will use that term, and a pod is simply just a bunch of AWS resources that are repeated 47 times. early on, before I even started here, a lot of the first pod was kind of created by hand and a little bit by scripts, and then along our journey we started using CloudFormation, and then I made the migration to us starting to use Terraform just because it seems to be a more mature and better tool. CloudFormation has a lot of quirks and it seems to be a little more difficult to use. So some of the resources, and I will get to the diagram in the next slide of the architecture, but just some resources include some EC2 deploy instance for each pod where we deploy the code. And then we have an auto scaling group that uses what we refer to as web workers, which are just individual instances that the web traffic flows through, and then RDS for the database backend. Then we use Elasticache to kind of cache some of those responses to the database. And then we have the NAT instances, which the web traffic flows through, and you'll see that in the diagram in the next slide. And then we have our network load balancers, S3 buckets to store some upload assets. Obviously, we have our DNS and Route 53. And then recently, probably a few years ago, we implemented CDN, and primarily we were interested in the WAF, the firewall, because there's a lot of DDoS going on and people scraping the site, so that kind of protects us in that aspect. And then the NFS to EFS servers, which is what this talk is all about. So here's kind of our current platform infrastructure. You'll notice over here, you'll notice this is one VPC, and then we kind of have it split up into two different availability zones, which in the region for redundancy's sake. So the load balancer will properly be able to route traffic to each of the regions. So we do have a DR plan if US East 1 goes down, and that is fun stuff. But for the most part, we rely heavily on US East 1 like most of the internet does. And the portions that we will be talking about in this talk are the NFS servers, which are in the old architecture, were just individual EC2 instances that we managed ourselves. And I'll get more into that as we move along here. So here's another diagram. It's just abstracting out everything that we don't really care about for this talk. And you'll notice this is the public traffic to the load balancer, and the NAT gateway goes to different auto scaling groups where the web traffic flows through. And then our pre-existing architecture that we no longer use, we had two NFS servers, and there was scripting involved to do some failover checks and to make sure they were matching up. And then if one failed or one had to be replaced, it would go over to the other one. But after a while, that kind of broke. So that was one of the motivations for us to move over to the Amazon EFS. And I will get to the description of that shortly. So the whole point of this talk and the whole point of this project was to move away from those redundant self-hosted NFS servers on EC2 instances and move to another service that is Amazon managed called Amazon EFS, Elastic File System. It provides scalable, replicated, good backups, and one thing that we really got out of this was it's very useful for disaster recovery, and that kind of, as an enterprise, that kind of became a thing that we had to have, which you should have anyways. Through EFS, it's constantly replicating to another completely new availability zone. So with that, we could, I believe it's US East 2. So with that, if US East 1 went down, we have some Terraform code, and then we can start up our websites from that backup recovery. So some problems that we're kind of solving here is, like I alluded to earlier, the broken replication between NFS1 and NFS2, and also there's no need to manage those NFS servers anymore. I don't know, like maybe once every several months or so, we'd have to restart that instance because AWS needed to put it on some new hardware, and it just started to become a pain. So all of those headaches are kind of gone. And like I alluded to before, an improved backup solution in another region. And we also, there's some cost savings, and I'll get to that a little bit later, because no longer we need to have those redundant EC2 instances, which would be 2 per pod, so 47 times 2. And then the cost all goes to NFS. And I don't have any numbers for if we saved yet, but I'm pretty sure we have. And since this is a new project, maybe in a year or so, I can do an analysis and see how much we saved there. But that was another motivation behind this project, was to save some money. So a little bit about
with regards to that savings, you're going to take into account like lack of management time, lack of having to deal with the replication checks and whatnot.
Yeah, actually, that's a great point. I, I don't know if I could put a number on that, but that's definitely something that could go into the report for like those upstairs. But I was just going to do fully like, hey, this is us operating on EFS versus operating on EC2. This is the differential like per month or so. But that's a great point.
That's one of the things I found is trying to script better or use more cloud-based managed services instead of trying to do things by internally managed scripts. Like, okay, the thing I was talking about before we started today, the Elasticsearch problem I'm having. If I took and moved our entire homegrown Elasticsearch system into, we use Azure instead of AWS.
Mm-hmm.
If I move that all into Azure's Elasticsearch, I don't got to worry about these outages. I don't got to worry about these rebuilds. I don't got to worry about these reboots, power outages, whatever. It's just going to run up there. But that's going to then free up me X number of hours a month, months a year, etc. And that is a pretty penny too. And the upstairs do like to hear about that as well.
Yeah, exactly. So a little bit of background about EFS. I believe, I don't remember when they created this, but it's not super new. I don't think it existed when we started, but along the way, we've been wanting to implement this for years. It's definitely the best practice. And it just, like I've said before, it just enables you to have a fully available file system that you can just mount onto pretty much any system you want. And everything is just kind of provided for you. And the storage capacity is pretty unlimited, and it has pretty decent performance with some tweaks along the way. So this leads us to the improved platform. As I said before, we deprecated those 2 EC2 servers. We will create a new EFS server per pod. Like I said, there's no more of that broken failover and replication. There's no need to increase the size of the volumes of those EC2 instances. That's something that we also had to do, which was annoying. And we no longer have to pay for those EC2 instances or worry about them in our savings plan. And it is a scalable and AWS managed solution that we can kind of set it and monitor and kind of forget about it. So that leads us to an improved diagram from the one I shared with you before, where we have the same traffic flowing through the NAT gateways, but this time we have a single EFS resource that has different mount targets for each availability zone, and it just kind of knows which to connect to and how to pull out the data, and it's all seamless. So it's very nice solution from what we had before. So now we're going to get into how we accomplish this. We originally wanted to use the AWS data sync, but we found that it was very slow for what we wanted to do. And that work began years ago, and it was just never prioritized until just recently last year. So it was nice to get this project up off the ground and running. There are some other options that we could have chose to do the actual migration of the data, GNU Parallel, MSR sync, and FP sync besides that data sync. And we chose FP sync. FP sync is just a wrapper scripting that launches a bunch of rsync processes in synchronous jobs. And we ended up finding that we could do 128 at a time. And that's how we transferred all of our files over to EFS. So we had a pod mount. This would be on the local system, and I'll get to more details of that later. And then we mounted over EFS, and we were able to transfer things in a little less than a few hours, depending on the size of the data store. So it was a big gain versus data sync, which seemed to take days. So that was a nice little thing. And I along my research phase, I did ask the question about uh, what the guys over at 2.5 Admins podcast thought about FP Sync. So if you're interested in that, what they had to say about that, I provided the link in the time code there. And these slides will be shared later. So that's pretty cool. So prototyping. Prototyping began kind of around late December. We did the first test with 8 concurrent jobs. It took about 12 hours on one of our pods. So we were kind of at that point we realized the utilization was pretty low, so we could increase the concurrent jobs. So we kind of, this was kind of where we started from. It took about 12 hours. We increased our jobs to 32, and the same data set was about 7.5 hours. So that was some improvement there. And the way we were doing this was we were actually using data that already existed and mounting EFS. So along the way, I kind of had an aha moment where we were already taking a backup AMI of both of the NFS servers. So for each pod, it was different. It was either using NFS1 or NFS2 because, like I said, the replication was slow and it was broken. So some of them weren't even properly redundant. So this whole project solved that. So we were able to take that AMI, which had all of the data we needed, and we were able to just create a temporary instance from that and do the transfer the morning of the migration. And I'll get to that in a little bit here.
Hey, Craig.
Yeah.
We've got a question from Suresh on the chat.
What's up?
Did you have to freeze any updates to the websites during the migration?
We did, and I'll get to that. I'll get to that when I get to the process. It's a good question, though. So this is the process that we came up with. We had 47 pods, so we created 47 individual Jira tasks for each pod, and we signed out to each of our team members. We have about 10 people on our team. We thought about ways that we could fully automate each of these, but unfortunately, because we were using some pre-existing infrastructure and replacing some infrastructure, we kind of had to do it one at a time. So instead of just one person doing all 47, we came up with some run books, and we successfully were able to facilitate the process that way. We did about 5 of them per night. And like I said, we came up with a couple of run books, which I will go through those processes in a second. And we utilize what we refer to as a CAB. It's an old term for Change Advisory Board, where we submit that's paired with the Jira task for each pod, just so everyone's aware in case things go bad and we have to go back. We were pretty successful with all of them. I think there was a couple that had a couple hiccups. There was one where some resources that were new were unfortunately deleted, and that was a day where I had to come in and create those on the fly, and that which helped with figuring out some of our DR process. So that was a useful accident. And then another one where we saw some unknown issues with some of the performance. So we ended up having to tweak the throughput on EFS itself. So we had another engineer that was in charge of kind of watching those after we did the migrations to tweak where our throughput would be. And each of our EFS kind of has different throughput because each of our pods are kind of, they're not all exactly 150, and not every single one has the exact same amount of traffic or the exact same amount of data. So it's nice that, and I'll get to how we implement that in a second. So here's we kind of, our process was kind of, as I alluded to before, up here was kind of, well, it doesn't really matter where the slide is. Right here. Our prep work was, we had 2 different stages kind of. We did prep work in the morning. And then we did the actual cutover. So that's where I will talk about the two different phases that we came up with. So as I alluded to earlier, we had cloud formation stacks, and we took this project to put some of our most of our infrastructure that we could into Terraform. We still have some work to move everything over, and that work will be happening when we're standing up all the infrastructure brand new from Terraform configs. But what we were able to do is we were able to come up with a set of Terraform configs with modules to be able to create the EFS and then create all of the other infrastructure that we needed to replace. So what this allowed us to do was it allowed us to create. Did a workspace per pod, and that workspace would grab the same configuration for each one. So the engineer that was setting these up didn't have to touch any of the Terraform code at all. They just had to set up a workspace and pass it some variables. So it's very powerful. And what that also allows us to do is say we want to update every single pod at the same time with, for example, like add a tag to something that we don't have. We're able to do that. So that's kind of a cool paradigm that we're utilizing right now. So we created a new EFS resource in each workspace ahead of the migration. So you could create this workspace pretty much whenever you wanted to, like the day before, stand up everything so everything's ready to go. And we hook our workspace into our version control provider, so that just pulled it from our Bitbucket code repository. And like I said, we had a single config we used to create. No, this is a separate step. We have a single Terraform config that we use to create the temporary EC2 instance, and then we mount, or it's already mounted, the backup AMI of the previous data, and then we mount the new EFS that we created from the workspace, and this is the command that we would run to do the transfer. And we typically do that in the morning because late at night, I believe at 0 UTC, it would take the backup. So that leads us to the question, which I will get to in the next slot, in the next couple slides here. I just wanted to share. This is the plan when we created each of the workspaces. So these are all 17 of the resources that we're creating new. We have our deploy instance here. We got our file system and our mount targets and the replication configuration. And we utilized some Route 53 records to do the actual mounting. We have some inventory workers that are not in the scope of this talk, but are necessary for some inventory updates. And then we had created a brand new auto scaling group. So those are kind of the resources that we created 47 times over. And this is just a little example of the Terraform code. If anyone's interested in the actual code, I'm sure I could take a copy and send it over. But this just kind of gives you the idea of how our code was organized with modules and passing variables and stuff like that. So the cutover process, and this goes exactly with the question. So during the cutover process, we established like 11 p.m. Central was when all of our dealerships from coast to coast did not have to do, like the developers did not have to do any builds to the websites to replace the code. So that gave us a kind of a, there was the website itself was not down, but the process of building a site and then replacing code on it was down. So we had a mechanism in our building system where we were able to block each of the websites from being built at that time. So then what we did was we would mount that new EFS system, that new EFS file system, to the deploy server, and then we'd be able to do the cutover from the previous migration that we did in the morning. So this was the final delta sync from our old data source, which was NFS to EFS. And then once that was completed, we were able to run through the process of updating the new deploy instances EIP. We wanted to utilize the same EIP that we did before, which is Elastic IP. It's just a IP address for that deploy instance that doesn't change. And then we attach that same backup volume, and that backup volume just stores some database backups that are ready to go for various systems to do backups. And then we would essentially be creating a new deploy server. So during this process, we had 2 deploy servers, and later on we would destroy the old one, but we had the current one, and then we would just run through our Puppet code for configuring the new deploy server, like we would do if we were to create a brand new set of pod resources. So everything just works well and fine that way. And then we also had another system, which we refer to as the rescue server, that does some job queuing tasks. So we had to make sure that we remounted that EFS to that after that was created. And then we added the new instances to take traffic into the pre-existing target group. And then we associated that new ASG that we stood up with the Terraform workspace to those existing target groups. And once traffic was flowing through and everything looked fine, we were able to unblock those builds with that mechanism that we blocked before. And then we would lock the Terraform Cloud workspace, and then we'd give it a few days and see how it went. And then we'd go back and clean up the old resources once we knew the migration was successful. So that was kind of the cutover process there. Yeah. So just a little summary here. Discovering and prototyping began around December 12th, and we finished our whole project on May 16th. Everything's been running very smoothly, and like Charles alluded to earlier, like we've saved a bunch of time on having to manage all those EC2 instances, and we'll find out what the savings are soon. But yeah, that's we archive the channel. We found that with our projects, we like to create like a temporary Slack channel that each of the engineers can kind of throw around ideas. And it was nice to be able to go back to that channel and to come up with my talks, because I was able to find some times and moments where we were doing some prototyping and throwing around ideas along the way. So that's kind of it. Our company is hiring both the DI organization and cars.com. So if you're looking for a gig, make sure you mention me. I'm on you can find me in the Discord under this handle. If you want to get in touch with me, you can feel free. I have all my contacts on my site. And if you would like the code, just let me know, and you can find the slides over here. And my YouTube channel is here. I still just have one talk on there, but I hope to have this talk, and I hope that giving these talks will motivate me to throw some more stuff on there. I will say that being a YouTuber is not like my high priority, but if I give a talk and I'm able to record it, I will throw it up on there, and hopefully it helps people out. So with that,
you never know what kind of benefits are going to come from this. Yeah.
With that, is there any questions, comments, or anything that people would want more explanation on, or details, or?
Suresh was asking if you could get the link for the slides pasted into the chat.
Yeah, absolutely.
Hey, Craig, this is great talk. This is excellent. I mean, in the massive scale that you took and, did that pretty much in one night, that was amazing. I have a question. Did you guys have a staging environment where you kind of tested this, and did you have any beta testers, like let's say a few dealerships or a few websites that you actually performed the whole thing, maybe on one pod and then tested them, or you just like did the whole thing and then hoped it worked?
Yeah, that's a good question. We're actually coming up with a so since Dealer Inspire kind of grew very fast, we do have a development server that's a single instance, but the way that data is stored is completely different than the paradigm of each of our production pods. So unfortunately, to answer your question, no, we didn't have a way to test it in a development or staging environment. we just came up with a process, and we were very, very careful with one of those pods, and we communicated out to all of our dealerships that we were doing this work and made sure the business was aware. And once that process was successful on that one pod, we were able to replicate it on 46 of the rest of them. So we didn't have really a staging environment to do the testing, and we were just able to perfect it on one pod and then duplicate it across the rest of the environments.
Okay, great. That's really brave.
It is. We didn't have a choice.
Yeah, yeah. I mean, yeah. Given the architecture, so I'm curious. You mentioned this 47 pods, and each pod has about 150 dealer websites. How do you split the websites on the pods? Like, I want to understand how you decide which websites goes on which pod, and then how do you route traffic to the exact website on the exact pod without like doing a trial and error.
Yeah, sure. So we have, for a while, we were creating, whenever we needed more infrastructure, we just created a new pod. So really, it was just sequential. We did pod 1, and then once it filled up, we moved to pod 2, and then once it filled up, we moved to pod 3. And then over time, we got to a point where we kind of plateaued on how many dealerships we have coming in and dealerships that are leaving our platform. So now we have a mechanism where it's just, it picks a pod, and then if it's full, it moves on to the next one. So really, there's no rhyme or reason to exactly of where that website's built on which pod. And the way that we route traffic to the pod is the CNAME for the www dot like dealership.a.com points to the pod number. So that's how the traffic flows to the appropriate pod.
Thank you. That answers my question.
Sure.
And last question. So it seems like all the website code is stored on the EFS, the NFS to EFS migration that you just covered. That's where all the website code is stored. Are the static assets also stored there, or are they stored separately on the S3 bucket that you mentioned earlier?
They're stored in the S3 bucket. So we have, for example, there's a bunch of different assets. There's the inventory assets, which are stored in a completely different location. And then for your question, the other assets are just stored in S3 bucket. And those are like when people log into a WordPress website, they just upload to the S3 bucket, and those are just pulled from S3.
Awesome. Thank you.
Mm-hmm.
By the way, sorry.
Go ahead, sorry. Go ahead.
Yeah, I had a follow-up question on the previous one because I was taking notes on the side, so I didn't have.
Sure.
Yeah. So the CNAME record, you said it points to the exact pod where that that's stored. Is this something? Do you also manage the domain for the customers, or even if they bring their own domain, you just tell them, hey, this is the CNAME, and please update that, because that sounds a little bit risky, but something that's doable, right?
Yeah. So that's a tension that we it's been troubling over the years. So we never really had exact policy. I know there's other providers out there that will force people to use their name servers, but we give dealerships the option. So we build a website, and then when the dealership is ready to go live with that website, they just need to update DNS to what we provide them. We provide them with a couple records, or we create the name servers that pulls other records, and then they're on our name servers, and then that's a lot easier for us to just then change those records, and then it routes traffic to the new pod. But that's kind of how we handled it. We've never really had an exact policy of if we do the DNS or they did the DNS. In my opinion, we should, but that's just how it's been.
Yeah. I mean, it seems like most of the time it's gonna work fine, but in terms of disaster recoveries or some disaster scenarios where you have to move a website from pod 10 to pod 11 for some reason, and then that's when actually it might be a problem. But otherwise, I mean, for most days that should be okay.
Yeah. So like in a DR situation,
Yeah.
we would create a brand new pod, and then we would just have whatever that pod went, say like a pod went down, we would just point those pre-existing records to the new one with another CNAME.
Okay, sounds good. Thank you so much for all the answers to my questions.
Yeah, absolutely.
So
And
I had a question then. So obviously this is, as you said, WordPress. What what are you doing with the MySQL component to that? Is that already in a AWS MySQL system or something, or what?
we use we use RDS. So we use Aurora. So it's just a self-managed MySQL.
Oh, okay.
Yeah, so the MySQL is not on the server itself. It's just a connection to it's just a config in the WordPress config to point to the RDS
Okay.
instance, RDS
So that,
a cluster.
yeah, so that wasn't affected at all by any of this project. It was
Nope,
just, okay.
nope. That was untouched. That was none of this was touched. Everything just worked fine there.
That's what I kind of suspected, but
Yeah,
the lack of mention, I figured I'd at least ask the question. So, okay.
yeah. So
Cool.
so there's actually an AWS best practice hosting WordPress platform, and ours is pretty close to that. So if anyone's interested in looking that up on AWS, it's pretty close to what we do. There's a little bit of differences, but for the most part, even before we knew about that, we were kind of already in the best practice. The EFS was like the last piece that really got us to being perfect. So that was kind of cool to realize we were there.
Yeah, hey, Craig, I'm a little curious about the like the timeline and challenges you had as far as going from like CloudFormation to Terraform. Yeah, I saw all your modules earlier.
Mm-hmm.
That makes a lot of sense. It just I've mainly just worked in Terraform, so yeah, I think it kind of makes me cringe a little bit thinking about transferring all this code, and I was just curious about the timeline and like challenges you had with going from CloudFormation to Terraform and what you brought over, and I guess what was from going on from scratch.
Yeah, so the way our CloudFormation works and the way CloudFormation does work is it's just one giant template file. So each resource we were able to take out and then modularize in Terraform. And for this project in particular, we just took out the pieces that we needed to recreate. So really, it was just creating everything from scratch in Terraform out of the gate. And like I said before, we have plans to move each of these pods to a new account structure, which we will have to come up with, like, say, we're a brand new company and this is the exact Terraform to create the brand new pod. Because right now, some of it is using like data sources and using already pre-existing infrastructure. But really, it's just a matter of just being able to look at the CloudFormation, look at the AWS console, and be able to recreate everything in Terraform. There's no like seamless way to transfer it over or convert it. So it's just a lot of understanding the infrastructure and being able to just write it in Terraform. And in my experience, writing in Terraform and the way that tool works is a lot more easier to use in CloudFormation. Hope that answers your question.
Yeah, definitely. That's just interesting to think about that. So I thinking about my work. Um, it's been brought up a little bit to do some things in CloudFormation, but we pretty much like Terraform, like mainly just like you said, it's a little more flexible and I just think easier to work with.
Yeah. And if there are some resources and stuff that you have to write in CloudFormation for whatever reason, like maybe it doesn't exist in Terraform or it's just specific to AWS, there are ways where you could facilitate that with Terraform and wrap the Terraform in the CloudFormation. So then you're not having to deal with the clunky CloudFormation UI all the time, which is just a pain in the neck to delete things and update things, and that it doesn't have the idea of planning. It's just you just deploy it and it goes, or it fails, and there's no like real feedback where you have in Terraform.
I have a question on the Terraform. So it seems like you use the same Terraform code to spin up all the pods, right? How
Mm-hmm.
do you how do you I think I'm still trying to frame my question, but I have it in my mind. So like you have all these pods that are probably numbered from pod 1 to pod 47. And then
Mhm.
when you run a Terraform, how do you know which part to run? Like, do you maintain like a profiles in the Terraform, or like I just want to know like the states, the TF state goes to the right, the TF state of the right pod goes to the right state, I
Yeah,
think.
so
Yeah.
all of the Terraform code, like the configuration that's defined in the repository, it's all the same. It uses the power of variables that you can define in the workspace itself, or you could use a file that would do it for you. And you literally just go into the workspace,
Yeah.
create pod 2, and then you would pass just each variable that's unique to that pod, which isn't too many. It's basically just the 2, and then it creates the brand new infrastructure from there.
Okay, cool. So it does use the variable. Yeah, I've never used
Mhm.
Terraform workspaces. I mean, I use ton of Terraform at work, but we just use everything as like, everything is configured as code, and then they just run from the files into a CI/CD system.
Yeah, to Terraform Cloud is is pretty neat. It's a lot easier to use if you're running Terraform a lot with multiple different people. It just organizes it better for you and it gives you that nice UI. But there are other ways where you could do all of this with setting up a proper S3 backend and DynamoDB locking mechanism. But we've found it to speed up um, provisioning these because it's just some clicks of a button and setting some variables. And another nice thing is they have this idea of variable sets. So if you have a shared IAM user, you could use it across all of those different workspaces. And a workspace in Terraform Cloud is a little bit different than a workspace in the Terraform CLI. So just keep that in mind. They use the terms interchangeably.
Okay, that's good to know. Yeah, I've never
Yeah.
used Terraform workspaces. Uh, and these Terraform workspaces seems like, and how do you run them? You just like, go on the UI and just, I'm sure there's like more nuances to it, like passing the variables, targeting the availability zone, but it's generally like you run it from the UI, right?
Yeah, so a workspace is just an abstraction organizational thought where it's just like you create a new workspace, and then really what they're meant for is really they're meant for like different environments, but we just took the same idea and applied it to the same set of pod. So in our Terraform workspace or in our Terraform cloud, if you log in, you'll see what you can do now is you can organize by project. So we have pod resources legacy, and then we create 47 workspaces under there. And then if we need to update anything, we can run all the workspaces pretty much concurrently. And then we have other projects for different resources, and then those workspaces are organized in different ways. So like say you had you wanted to create an app or a service or whatever in AWS, you could use 3 different workspaces for each of your environments, and then they could be unique, but the code is still coming from the same place.
I see. I think I'll still need some time to wrap my brain around
Sure.
the abstraction of workspaces and how it relates to like actual deployments.
Yeah, absolutely. If you go on HashiCorp's website, they have awesome tutorials about workspaces.
That's awesome. Yeah, I'm a big HashiCorp fanboy. I use like Terraform, Vault a lot in my work. Yeah.
Nice.
Do you have any like CI/CD process when it comes to like all these infrastructure? I mean, I know you have these workspaces, but like, is there a way? Like, how does it work on a continuous basis? Do you push it to a GitHub repo that gets to the workspace and then gets executed automatically, or it's all like manually triggered on a need basis?
Yeah, so if you needed to change some infrastructure, you would change it in the code, and then it would automatically push out to the workspace, and then it does a plan, and then you have to manually apply it, so then you can make sure it doesn't break anything. So
Perfect.
that's kind of how that currently works.
Perfect.
And then people can review it. And
Excellent. Yeah, that was my next question. Like, because I know you're a fairly small company, do you still have like the change management process? Like, do you have to still go through the change approval process? That's a completely different sort of question, probably, but still. Just curious.
Yeah, if we're updating production, we definitely go through that change process, because like updating these pods, like, and all the resources and stuff, it doesn't happen that often. Might have to upgrade like a Redis cluster or add a tag here or things like that. So
Got it.
we
Yeah.
definitely go through that process.
Yeah. Okay, that makes sense. I think what he's saying is the infra update doesn't happen very often, but the websites are definitely updated multiple times a day. And how does that process work? Are they kind of like, and I'm not a WordPress expert at all, and I have no idea how that works. But how are those managed by the dealerships?
Yeah, so the website code is just defined in a repository, and then developers have a local environment that they spin up, and then they make their changes to the code, and then they push it to the dev server and make sure everything's running properly there. And then when they want to push it to production, they push a build button, basically, that kicks off a set of, well, we currently use Bamboo for that. And it's literally just copying, it's doing more than that, but it's for the most part, it's just copying that code in, it's building it in a temporary directory on the deploy server, and then once it's finished, it copies it and replaces the production directory. So it's really just doing like an rsync.
Okay, excellent. So it seems, is that when customers make the updates, is it in their own GitHub repos, or are they provided by you guys, maybe through a portal or something?
So website customers won't be making any changes that would affect like the code of the website. Only our teams internally, our developers, would be doing that. If the customer is doing anything on the website, they're just logging into WordPress, and then it's just manipulating the RDS instance. So it's never touching the code. So everything I talked about here, customers would not be changing.
I see. Okay. So they'll make the changes from the UI, and that would probably make the update into the GitHub repo.
No, it doesn't touch the repository. It would just update the database of that website.
Oh, I see. Okay. So that's how WordPress works. Okay.
Yep.
I'll look more into that. Thank you so much.
Yeah, no problem.
Cool. Anybody, any other questions or anything? No, Craig, thank you very much for a fantastic presentation. A couple people had to drop off earlier, unfortunately. But yeah, no, this is very informative. I got a couple of things out of it that I wasn't expecting to, which is why I love these presentations. Like, you never know what you're going to come across. Like FP Sync, I actually use rsync in a couple of places, so I might want to look at that as a way to possibly enhance where I'm using rsync already. So
yeah, it's an awesome tool. It just works.
It sounds like it, yeah.
So even if you're just copying a bunch of data with rsync, just use FP Sync, and it's going to speed it up depending on how much compute you have available.
Yeah, we were using rsync as part of the as part of our CI/CD process using CodeShip, and we just, because we're now, our new version we just released, we're on Netlify, we don't need CodeShip anymore. Most of our rsync needs have just completely disappeared. But I'm going to keep this in mind in case I needed. Excuse me. In case I needed to get in the future, because yeah, the idea of having multiple threads, multiple jobs running at the same time, like, yeah.
That's awesome.
A very nice thing.
And I do plan to write a detailed blog post for my company and throw it up on our company website. So when I do that, I'll make sure I throw it everyone's way.
Yeah, I'd love to see that, definitely. Cool. All right. So yeah, so PowerShell next month. If anyone's got anything they want to have as a topic or want to present on in the future, let me know. We've got the next couple months after August open. I've got one or two small ideas myself. I'm still trying to formulate those a little bit more. But yeah, Greg, thank you very much. Everybody else, thank you for coming. And we'll go ahead and call it here. So thank you much. Have a great Saturday.
Sounds great.
Sounds good. Thank you, Craig.
Yeah, no problem.
Bye.